Gianna, we ready?
Yeah, I did it. Class 18 now. It's your birthday.
Gianna, it was your birthday?
Over the weekend.
Oh, happy birthday. What'd y'all do?
What?
What'd you do?
I went skiing and then I hung out with friends.
That's fun. Where'd you go skiing?
Just like Blue Mountain.
How were the conditions?
Oh, it was pouring, but that was really fun.
Okay. I didn't know if it was snowing there.
No, it was absolutely fun.
It was still raining?
It was
Okay.
raining, but that's okay.
Is that like a borrow pencil?
Yeah, there's a cup on my desk. The new pencils, yes. They're very new. All right, so the first part of this lesson, a lot of the lesson is going to be definitions, just terminology that we need to know. So let's go through first. Right, so angles are now going to be formed by rotating a ray about its endpoint. This is a new unit. We're starting trig. We're finally there.
Pre-calculus took it off trig.
Pre-calc is all trig, yeah.
So no more.
No more what?
Like what we're doing
No more logs. We're done.
for the year.
For the year with logs, yes.
Oh my god.
Okay, so what do I mean by this? So here's a ray. Here's its endpoint. Now what happens is, if you go to the endpoint and basically you rotate this X amount of degrees, that creates the other ray of the angle. So let's give some more definitions before I draw anything. We're going to say the initial side is that straight horizontal ray that I just sort of drew. That's your initial side. And it's always going to be on the positive side of the x-axis. So on positive side of the x-axis. The terminal side is where it stops when rotated. So we always start at our initial side and then we're going to rotate. If we're going to rotate in a positive direction, it's actually counterclockwise. Let's write this out. Give me another color. So counterclockwise will be a positive angle. And clockwise will be a negative angle. And you guys probably remember this from geometry. Do you guys remember the circle with a loop through it? You guys don't remember that? Okay, that circle with a loop through it, this is called theta.
We're using that.
Good. And really all theta is an unknown angle. You know how we usually use x to represent an unknown side? Well, usually Greek letters are used to represent unknown angles, the most popular being theta. Sometimes you'll see a beta, which is like a weird looking B. So this is a Greek letter used to represent an unknown angle. So let's go back, draw my axes. So I'm going to have my initial side. My initial side is always the positive side of the x-axis. So see what I just drew in pink? That's my initial side. And now we would basically rotate this to create the other ray of the angle. Now this green one is my terminal side. Pink is our initial side. And right here, that angle that was created, see how I rotated counterclockwise from my initial side to my terminal side? That's our theta. And this would have been a positive angle measurement.
So if we went down, we would have been like,
Yep, and that's what I'm going to do right now. So once again, my initial side is always the positive side of the x-axis, always your initial side. Oops, where'd that go? Always your initial side. But now let's say my angle was negative. So if my angle was negative, that means my terminal side would now be down here, and my theta would have been negative.
Sounds positive. Negative.
Yep, left side is positive, right side is negative.
Wait, so the terminal's blue?
This one, the terminal side is the blue one, yep. All right, another definition, coterminal angles. So coterminal angles are going to be angles that terminate in the same place. And I'm going to put a little star, and I'm going to say any coterminal angles differ by an integer multiple of 360 degrees. And I'll explain to you what I mean by that in a minute. All right, let's say I have a 90-degree angle. And now I want to create a coterminal angle with my 90-degree angle. Now, my 90-degree angle, its terminal side is right here. Do we agree? This is my angle. So I want to create another angle that has that same terminal side. Well, this is always our initial side. Coming from here. What would I have to do now? How many degrees would I have to rotate to come back here again? Isn't that a full circle that I've just created? How many degrees is that full circle? 360. A full circle is 360. So if I have 90 degrees plus 360 degrees, that's going to give us 450 degrees. So that's telling me 90 degrees and 450 degrees, they are coterminal angles. They're both going to end on that green terminal side. Could I do another full circle if I wanted to? Here. If I did another full circle, what would that be? 90 plus what? Not 450, nope. 360 plus another 360, right? Because now we have two full circles. So it's going to be 90 plus 720, which is 810. Is there ever a limit to how many coterminal angles we can have? No, there's no end. There's no end to how many coterminals, because can't we always just add another 360 degrees? All right, now let's say I wanted to go in the negative way. So let's say this is my terminal side, but instead of going counterclockwise, let's say I went clockwise this way, and still ending back at that terminal side. But now if I'm going clockwise, it's not going to be 90 plus 360, it's going to be 90 minus 360 because I went in that negative direction, which will bring us to negative 270 degrees. Okay, so now what I want us to do is I want us to find the smallest positive coterminal angle. So the first one's going to be 2123 degrees, 2,123 degrees. So if I want the smallest positive coterminal angle, do you think I'm going to add 360? No, what do you think I'm going to do? Keep subtracting 360. So I'm going to say 2,123 minus 360 degrees. That's going to give us 1763. Do you think I could go smaller? Yeah, we could go a lot smaller. Now I'm going to take 1763 and I'm going to subtract again 360. That's going to give us 1403. Now I'm going to take that 1403 and I'm going to subtract 360. That's going to give me 1043. I'm going to take that 1043. I'm going to subtract 360. That's going to give me 683. I'm going to take that 683, subtract 360. That's going to give me 323. What happens if I subtract 360 again? It becomes negative. Did I want negatives? No, I said the smallest positive coterminal angle. So what is that here? 323 degrees. Yeah. Mm-hmm. All right. What happens if I give you same directions I want the smallest positive coterminal angle, but now it's negative 555 degrees. What do you think I would do this time? Add 360 because we need to move to the positive direction. So I'm going to have negative 555 degrees plus 360, which is going to bring us to 195 degrees. Is it worth adding 360 again? Why not?
Because we're already the lowest possible.
Yes, we're the lowest possible positive coterminal angle. Maya, what's wrong?
I don't want to do this.
You don't like angles? It's going to be a lot of angles. All right, so now this next part, oh, did you want to see?
Is the homework is this?
You'll see. Yeah, you're going to have homework.
Is homework just this though? It's just like adding.
No, this was just an intro part of something bigger. There'll be some of these questions for homework. All right. So now we're going to be working with coterminal angles. Sorry, terminal angles. Working with terminal angles. All right, when we're working with terminal angles, this is going to be our process every time. What we're going to do is we are going to construct a perpendicular from a point of the terminal side to the x-axis. And I'm going to put in parentheses, never the y-axis. So your perpendicular is always only allowed to go to the x-axis, never the y-axis. That's aggressive? Yeah, I needed to stand out. Yeah.
Parentheses aren't aggressive.
No.
It's the all caps.
It's the
It's
caps.
the inclusion of it with everything else.
All right, by doing this, we will always form a reference right triangle. All right, so what would this look like? So let's say we have our initial side, right? And then we have our terminal, we have our theta angle. And let's say the terminal side is over here. All right, we never work with obtuse angles. We never work with obtuse angles. So what are we going to do? What we're going to do is we go to the terminal side. We go to a point on the terminal side. So let's say this is point P, right? It's x comma y. What you're going to do is you're going to go from that point P and you're going to drop down a perpendicular to the x-axis. Your theta will be here. The bottom side of this triangle will be x units long. The vertical side will be y units long. And And really what you're envisioning is that this triangle is part of some circle, some unit circle. And if this triangle is part of some circle, what do you call a segment from the center of the circle to the rim of the circle? Does anybody remember that name from geometry? A radius, yeah. So this will be R for radius. That will be our radius of the circle, that hypotenuse. All right, we're going to put this sort of on the side burner for a minute, and we're just going to recap our trig functions. Did everybody get the triangle circle? Anybody still copying that? Okay. So when I say let's recap our trig functions, what special word am I thinking of that helps you? You got it, SOHCAHTOA. Yes. It's all about the SOHCAHTOA. All right, so if you remember, so goes with sine. And remember, we have sine, we have cosine, we have tangent. There is never a trig function, Matt. There is never a trig function that's able to stand without an angle. So it's always sine of an angle. We'll say theta. So sine goes with so. What do you think O and H? Do you guys remember what that represents? Opposite over the hypotenuse. You got it. So sine is S-I-N-E. The way we shortcut it is S-I-N. And this represents opposite over the hypotenuse. Yes. Yep. All right, now go back to my right triangle up here. Theta is my angle. Which variable did I use to represent opposite? We have x, we have y, we have r. So opposite theta is y. So this is going to be y over the hypotenuse. Which variable did I use to represent the hypotenuse? Not y, no, r. Hypotenuse is always across from the right angle. So sine of an angle will be opposite over hypotenuse or y over r. Right. There is another function that is the reciprocal of sine. Does anybody know what that's called? Oh, no, that's the inverse of sine. It's actually called cosecant. Have you guys ever heard this before? So cosecant, similar to sine, always needs an angle. And the way you shortcut cosecant is CSC. And really all that is the reciprocal of sine. So if sine is opposite over hypotenuse, cosecant will be the hypotenuse over the opposite, which according to our right triangle would be r over y. We're going to need, there's going to be 6 trig functions that we need to have memorized. Yep. All right, so that was all for our so. Now let's go to our ka. Who remembers which trig functions goes with CAH? Cosine. And remember, similar to sine, cosine can never stand alone. The shortcut for cosine is COS. And this is going to be A over H, which is going to be our adjacent over our hypotenuse. Go back to our right triangle. Everything's in reference to theta. Which variable did I use to represent the adjacent? So here's theta. We have x, we have y, we have r. X, you got it. So it's going to be x over the hypotenuse, which we said was r. So similar to sine, cosine has its reciprocal function, and it's going to be called secant. And the shortcut for secant is SEC. And that is going to be the hypotenuse over the adjacent, which will be r over x. All right, now let's go to our last one, TOA, which is going to be tangent. And similar to the others, it can never stand alone. It has to be with an angle. So we're going to have tangent of theta. The shortcut for tangent is TAN. And that is going to be TOA, which is opposite over adjacent. Which, based on our right triangle, opposite theta is y and adjacent is x. And just like the other two, there is a reciprocal function. Which is going to be cotangent, which we shortcut as COT. And that is going to be the adjacent over the hypotenuse, which based on our triangle, not hypotenuse, adjacent over opposite, thank you. And according to our right triangle will be x over y. You want to have all of these memorized. So we want to memorize. All right, so how will I use this? Are we ready? Can I move on? Yes? All right, let's do some examples. I want us to find all trig functions for an angle when terminal side contains the point 512. Okay, so first thing we're going to do is get a diagram going. So find all trig functions for an angle whose terminal side contains the point 512. So first thing I'm going to do now is plot the point 512. So I'm going over 5 on my x and up to 12 on my y. So here's the point 512. And remember, my initial side is always what? The x-axis, right? The initial side is always the x-axis. And the terminal side is now going through that point. There's my terminal side. We always want an acute angle, but by me making this angle exact, is that an acute angle? Yeah, because wouldn't this be 90 degrees, the two axes meeting? So anything below that 90-degree side, that y-axis, is an acute angle. So here is my theta. And now what we're always going to do is we're going to go to that terminal point and drop down a perpendicular. It's a little bit messed up, but all right, so now let's label some parts of this triangle. How many units did I go on the x-axis? 5. How many units did I go on the y-axis? 12. Do you all remember in geometry, there was a triple, not 7, but it was a triple, 5, 12, 13. So that hypotenuse is 13. Let's say it wasn't a triple. What do you think you would have to do to find that last side? Pythagorean theorem, right? If it weren't a triple, we would have to do the Pythagorean theorem to find that last side. So now that I have all 3 parts of the triangle labeled, now I can go and find all the 6 trig functions. So I want sine of theta, cosecant of theta, CSC, I could actually write it. We want cosine of theta. We want secant of theta. We want the tangent of theta. And the last one will be the cotangent of theta. And now I'm going to rewrite that special word that helps me out, SOHCAHTOA. And everything is in reference to this angle theta. So for sine, which 2 sides do we pair in a ratio? It's so. Opposite and hypotenuse, O and H. According to my triangle, which side is opposite of theta? 12. And the hypotenuse is 13. So sine of theta is 12 over 13. Now, if you all just remember that cosecant is the reciprocal of sine, what should I do now for cosecant? Just flip the 12 and the 13. So this becomes 13 over 12. Now we want cosine. Which one is cosine? So, ka, or toa? Ka. So ka pairs A and H. So which side is adjacent to theta? 5. And the hypotenuse is still 13. Now secant, if you remember, is just the reciprocal of cosine. So instead of 5 over 13, it's going to be 13 over 5. The last 2 trig functions, tangent is TOA. So now I'm back to theta. I want the opposite, which is 12, and the adjacent, which is 5. And cotangent's just the reciprocal of tangent. So we will flip 5, 12, and 5 to make 5 over 12. And these are our answers. All right, another one.
They get more complex with the problems. Do you want like decimal answers or like?
No, we'll probably leave radicals. We're not going to really deal with decimals. So we're going to have sine of theta. Oops, sorry. Nope, that's not sine of theta. I'm going to say given negative root 3, comma, root 5 on terminal side, find 6 trig functions. I think there's a ghost that lives in here because it happens a lot. Did you not hear that?
No.
Really? Nobody heard that? It's like the strings on the window curtain, whatever that is, blinds, they like are getting pulled. No, I'm serious. It happens all the time. And it doesn't move. Like the blinds don't move, it just makes the sound.
Maybe it wants to stop learning.
It's done learning. All right, let's do this. So we are going to plot this. It doesn't matter whether you know what root 3 or root 5 is as a decimal. It does not matter. What you need to know is that this is a point x comma y. So I'm going negative root 3 units to the left. How do I know I'm going to the left and not to the right for root 3? Because it's negative. So I'm just going to pretend and say, okay, well, this is negative root 3 right there. And then I'm going root 5 units up. I'm going to say that's root 5. So the point negative 3 root 5 is the point right over here. And now we're drawing our terminal side to that point. So technically, this is my angle, right? But do I ever want an obtuse angle? No. So what you do is you're going to drop down your perpendicular, and then you're going to use this acute angle inside that right triangle. Do we all agree our height is root 5 and our x base is negative root 3? Right, so now what we want to do is just use the Pythagorean theorem. So we need to find the hypotenuse. A squared plus b squared equals c squared. When you're using the Pythagorean theorem, it does not matter which side you call A. It does not matter which side you call B. But what does C have to be? Must be hypotenuse. Yep. So we're going to have negative root 3 squared plus root 5 squared equals r squared. Just 3 and 5, you got it. 3 plus 5 equals r squared. 8 equals r squared, and now we square root both sides. Can we simplify the root of 8? Yes. I could break this down into 4 and 2, and then 4 becomes 2 and 2. So the radius will be 2 root 2. Maya, you're killing me. This is a bad lesson to sleep through. All right, now we need our 6 trig functions. So I'm going back to my SOHCAHTOA. So I'm going to have my sine of theta. Do we agree that's going to be root 5 over 2 root 2? Right, opposite over hypotenuse. There's a problem. Who knows the problem? You can't have a radical in the denominator. Who remembers how to rationalize? Aaron, what do we do? Yep, you multiply it by the radical in the denominator. So I'm going to multiply top and bottom by root 2. So in my numerator, I get root 10. In my denominator, I still have that 2 on the outside. So it's 2 times, what's root 2 times root 2? 2. So we are root 10 over 4. All right, now we want the cosecant. Well, isn't the cosecant just the reciprocal of sine? So I'm going to have 2 root 2 over root 5. Once again, what's the problem? The denominator has a radical. This time, what should I multiply by? Root 5. When you multiply by root 5 this time, you get 2 root 10 over 5. All right, I want you guys to find cosine, secant, tangent, and cotangent. You all find those, and then we'll go over them. After this, there's just one more thing I need to show you. How am I doing on time?
Oh, so bad. So many stop right now.
So given now. I'm not trying, Maya. You should do it yourself if you're doing
Finding all 6 of them.
We're finding all 6 of them, yeah.
Yes.
When it's negative root 3 on the bottom, you have to do negative root 3.
No, you could just leave the negative on the bottom. Just do root 3 times root 3.
Wait, you said negative on the bottom?
You can leave the negative, it's fine. So you guys are working on cosine of theta and the secant of theta, the tangent of theta, and the cotangent of theta. All right, who knows the cosine of theta? What'd you get? Negative root 6 over 4. What about the secant of theta? Nobody? Good. 2 root 6 over negative 3. If you wanted to sign that negative to the numerator and do negative 2 root 6 over 3, that's fine also. Anybody need to see me do either one of those? Cosine or secant? All right, what do we get for tangent of theta? Nico?
Root 15 over negative 3.
Root 15 over negative 3. What about cotangent?
Negative root 15 over 5.
Anybody need to see me do either one of those? All right, I say we stop here.
Yeah,
I'll do the
okay.
last part next class. You will have homework tonight, though.